Welcome to my channel Suriyas Academy. If you are new to my channel, then hit the subscribe button and press the bell icon for more interesting videos. In today's video, we are going to discuss about binary addition with multiple rows. In the previous video, we had already discussed about simple binary addition, that is addition which contains only two rows. We had discussed those details with basic 5 simple rules. If you want to check that video, then the link will be given in the I button or I link. You can watch it. Okay. Now, moving on to the topic binary addition with multiple rows. For adding this multiple rows, we are having two methods. First method, the example what I had solved here. Second method, I will explain it. Whether you can able to use it, you can use that methodology. So now moving on to the video. First I will explain about the second method because it is related to the simple binary addition, that is the first method. What we will be doing in the simple binary addition is we will have a basic 5 rules and we will be adding the two numbers, and with some bit and the carry bit the addition can be done. So in the second method for multiple rows, how it can be done is we have to add two rows at a time. Consider this example which contains first row as 111, second row as 100, 111, third row as 111, fourth row 111, and fifth row 111. This is the 5 rows the binary addition has to be done. Now there arises a question, why we have to learn this binary addition with multiple rows, or where it can be used. This multiple row addition can be used in the binary multiplication. Suppose when a number is multiplied by a 4-bit binary or a 5-bit binary, 5 binary digits or 5 binary digits, then 5 rows you will be getting when multiplied. So we have to add all those 5 rows. So in multiplication, this multiple row addition can be very useful. Now coming to the point, discussing about the second method. The second method is already we know to add 2 rows at a time. That is the normal binary addition. So in the second method, what is the methodology they are discussing it? Suppose if we are having 5 rows, we have to add 2 rows at a time. That is, we have to add this 1 and 2. We have to add this 1 and 2. And then again, you have to add 3 and 4. And finally, add the resultant of 1 and 2 with the resultant of the 3 and 4. And finally, you will get another result. And with that result, you have to add the 5th result. That is the 5th row. And then you will be getting the final answer, which will be the same as we are going to discuss in the first method. But what happens is, at the exam point of view, there will be so many additions you have to carry and it will be a time consuming process. So let's move on to the simple first method, which will be very useful for you. Now moving on to first method, here we are given a table, decimal and a binary value. The decimal value starting from 0 to 7 is given and their concerned binary values are given. Suppose for 0 it is 0, for 4 100, 7 111. Suppose if it doesn't know how to convert a decimal to binary, just consider a simple example 6. 6 when divided by 2 will give 3. The idea is we have to continuously divide the number by 2 till it reaches a minimum value and the remainders are noted, and finally we have to write from the bottom to the top. If you want, check my previous video, decimal to binary video. Okay, 6 when divided by 2 will give 3. The remainder 0. 3 when divided by 2, 1. the remainder 1, and finally 110. From the bottom to top it is written as 110. In the 110 also, the last digit 0 is called the sum bit and the 11 is called the carry bit. Okay, now we can move on to the problem. We are having here 5 rows, 111, 111, 100, 111 with final row 111, 101. This is the problem. We have to add the 5 rows binary addition. First we have to add the last row and find the decimal value, and with the decimal value we are going to substitute the binary value as a sum bit and the carry bit. That is the methodology. So adding 1 plus 1 plus 1 plus 1, 4 ones we are having the decimal value. For your representation I had written this row as a decimal value. If you can do it on your own, you doesn't need the decimal value. For your representation I had written here. So the decimal value is 4. For 4 the binary value is 100. So for 100, the last bit 0 is called the sum bit and the other 2 bits are called the carry bit. So 0 is written here and the carry bit 10 is written in the next 2 digits, that is 10. The color variation has been given in the carry bit for your clarification. So in the next 2 bits the 10 is represented as a carry bit. Okay, now let's move on to the next column. 1 plus 1 plus 1. So here the carry is 0. So 0 plus 3 ones we are having. So the decimal value is 3. For 3 the binary value is 11. So 11, the last one will be the sum bit and the remaining other bit will be the carry bit. So 1 will be represented here and the other one is represented here. Already we are having a 1. For 4 we had written 10 as in the second column. So for 3 now 1 and then another one is represented in the blue color for 3. So now the third column we are going to add, that is 1, 1. Already in the carry we are having 2 ones, again 1, 2, 3, 4. Here 4 ones, so total 6. 6 binary value is 110, 0 as sum bit and 11 as carry bit. So 0 as sum bit and 11 as carry bit. This blue color represents 11 for 6. Again this carry bit 1 plus 1, 2, 3, 4. Total 5 ones we are having. For 5 the value is 101. The last digit 1 should be written and 10 should be written as the carry. This 10 should be written as a carry. So for 5, 1 is written here and then this 10 brown color it represents. Already we are having 1 in the previous thing, don't get confused. For this 5, 1, 101, 1 is represented as sum bit and 10 as represented as a carry bit. Again we want to calculate this row. So carry 0 plus 1, we are having carry as 1, again 1, 2, 3, 4. So 4 plus 1, 5 we are having. Again for 5, 101, 1 is represented here and again 10 is represented. This blue color represents the 10, that is for 5, the remaining carry bit. Already we are having 10 in the brown color for the previous 5, don't get confused. So for the next 5, 1 is given here and 10 is represented here. And then we want to add the last column. Here 0 plus 1, we are having carry 1, 1, 2, 3, 4, 5. 5 ones here and a carry bit which equals 6. For 6 the value is 110. So 0 is written here and then the brown color 11 which represents for 6. Already we are having this 101 for the previous additions. So now this for 6 it is represented as 11 in the brown color. Again we are not having any number of columns here. the columns has been completed. Still we have to evaluate the carry bits here. So the next column is 1 1, which represents 2. The 2 value is 1 0 with 0 as sum bit and 1 as carry bit. So for 1 1 the value is 2, 0 as sum bit, and again the carry bit as 1, this blue color. For this 2. So again this 1 1 represents for 6, 0 represented, and then remaining 1 1, this brown color represents the remainder carry bit for 6. For 2 it is represented in blue color, the remainder 1. So again 1 plus 1 2, again 2 for 2 1 0. So 0 is represented here and the final 1 is represented here. There is no other carry here. This is the final number. So 1 is directly written here and 1 is the final resultant sum. So the final answer value will be the 1 000 0 110 10. That is 1 000 0 110 10. This is the methodology to be followed. This methodology can be helpful when we have more than 5 rows also. Whatever number of rows, using this table, decimal to binary conversion, just a simple rule. Find the decimal value, substitute it binary value, and in the binary value, consider the last digit only as the sum bit, and the remaining take it as a carry bit. That is the simple rule to be followed here. In the previous method, it will be second method. It will be a time consuming for adding 2 rows. Suppose if you are having 5 rows or 8 rows, it will be a very lengthy process for you to add. So just recall this methodology and solve it very easily. Just a small recap. We are representing the decimal value with binary, and here we are having 5 rows, and we are adding and find the decimal value, and for the decimal value we are going to substitute the binary value, and in the binary value the last digit considered as a sum bit is considered as a sum bit, and the remaining bit is considered as a carry bit. Again we want to add all those carry bits with the addition. So each time the carry bits has to be counted and added with the binary numbers, and finally again the decimal value found, again the binary value is substituted. Even when the numbers has been completed, the carry bit has been considered here for 3 bits here. Here the number has been completed, but still the carry exists. So we have to consider till the final value or till the carry bit ends. So that is the final answer, and that is the 1 000 110 10. Okay, that's all for today's video. We'll catch you in next video. Thank you. Keep supporting Suriyas Academy. Thank you.